The AI world just had one of those explosive weeks where everything feels like it's moving at lightning speed. Meta unveiled a vision breakthrough that could change how AI robots actually see and understand the world. Google dropped a shockingly small but insanely powerful model that runs right on your phone. ByteDance armed AI with bug hunting skills that work like a heat-seeking missile in giant codebases. And Microsoft quietly built something that could become the new standard for how we design AI prompts. Think of it like HTML, but for artificial intelligence. So today, let's break it all down. Meta's Dynov 3, the vision revolution. We'll start with Meta's Dynov 3. This isn't just another vision model. It's a self-supervised AI that learns without human-labeled data. That's huge because labeling images is usually one of the most expensive and time-consuming parts of AI training. Instead of waiting for people to tag photos with tree or car, Dynov 3 trained itself by scanning 1.7 billion images, finding patterns, and teaching itself what objects look like. Why does this matter? Because robots and AI systems trained only on labeled data are always bottlenecked by human effort. Dynov 3 cuts that bottleneck entirely. It can instantly learn from the endless ocean of unlabeled data: street cams, drones, satellites, even your phone camera. The architecture is what Meta calls a frozen universal backbone with 7 billion parameters. Frozen means you don't retrain it every time. You just plug in lightweight adapters for new jobs, whether it's spotting cracks in a bridge, counting crops in a field, or helping a robot pick up fragile objects without breaking them. And this isn't just theory. NASA's Jet Propulsion Lab is already using it to help Mars rovers see better without heavy compute costs. The World Resources Institute used it to cut canopy height errors in Kenya by 70%. Compared to Dynov 2, this is a massive leap. Training data jumped from 142 million images to 1.7 billion. Parameters grew from 1.1 billion to 7 billion, and performance now beats domain-specific models without fine-tuning. Imagine a humanoid robot with this power. It could walk into a factory it's never seen, instantly understand the layout, identify hazards, and locate components. No training required. That's how close we're getting to truly general-purpose robots. Call to action plug. By the way, if you've been watching all these AI breakthroughs and wondering, cool, but how can I actually use this in my life? You're not alone. That's why I made the AI Income Blueprint. 7 proven ways people are using AI to build income streams on the side. No tech skills needed. It's free. Link in the description. Google's Mini Beast, AI on your phone. While Meta went massive, Google went the opposite route, ultra compact. They just launched Gemma 3270M, a tiny 270 million parameter model designed for extreme efficiency. Here's why it's a game changer. In its INT4 quantized form, it can run 25 conversations on a Pixel 9 Pro using less than 1% of the battery. That means an AI assistant could run all day on your phone without touching your battery graph. It runs entirely on-device, so your data never leaves your phone. Massive privacy win. It uses a 256,000 token vocabulary with 170 million embedding parameters, so it handles rare technical words like medicine or law effortlessly. Even better, fine-tuning it takes just 10 to 20 examples. Developers can build custom AIs for businesses in an afternoon. Companies already use larger Gemma models for multilingual moderation. Now, they can carry multiple specialized models in a single device and switch instantly. ByteDance's ToolTrain, the bug hunter. Now, let's move to ByteDance, who solved a different but massive problem: navigating giant codebases. If you've ever tried debugging a huge project, you know the pain. Finding where the bug actually lives is brutal. That's called issue localization, and current LLMs struggle with it. They wander or make bad tool calls. Enter ToolTrain. It teaches AI models to use tools in the right order with a 2-step training. 1. Supervised fine-tuning for the basics. Second, reinforcement learning with tool integration for multi-hop reasoning. The result, Repo Searcher, their lightweight agent, crushed benchmarks. On real GitHub issues, the 32B model hit a 68.55 recall, beating even Claude 3.7 Sonnet. And the 7B version outperformed many 32B models. That means smaller, cheaper models can now outperform giants in debugging, and that's going to save developers endless hours. Microsoft's POML, HTML for prompts. Finally, Microsoft's move may not sound flashy, but it could reshape prompt engineering forever. It's called POML, Prompt Orchestration Markup Language. Think of it like HTML, but for AI prompts. Right now, prompts are messy walls of text with roles, tasks, examples all mixed in. POML fixes that with semantic tags, m-, n-, and /. It makes prompts clean, reusable, and scalable. It supports embedding documents, tables, images, and separates formatting from logic, like CSS does for HTML. There's also a built-in templating engine with loops, conditionals, and variables for dynamic prompts. Microsoft even released a VS Code extension with syntax highlighting, autocomplete, live previews, and SDKs for Node.js and Python. This is open source under MIT, already on GitHub, and could become the standard way to build AI prompts at scale. So here's the big question. Which of these 4 breakthroughs do you think will change the world fastest? Meta's vision, Google's Mini Beast, ByteDance's Bug Hunter, or Microsoft's HTML for AI? Drop your thoughts in the comments. I'd love to hear your take. And if you haven't already, hit that subscribe button so you don't miss the next wave of AI updates. Thanks for watching.